So, when I said the right thing to begin with, but then I switched it. I said, I talked about the domain. I should have left well enough alone. When I'm talking about the arc sign, you remember it looks like this. So the domain is from minus 1 to 1. And the range goes from, if you can see, that's 1.57 or pi over 2 approximately. And down here, 1.57, only it's negative. And so that's approximately equal to negative pi over 2. So it is the range. It is the range. I should have said it's allowed to be in that range. So anyway, it's not the domain, because the domain goes along the x-axis. This is the domain. So I'd be talking about negative 1 to positive 1 if it was the domain. But it's not. Okay, so let's see here. We're solving trigonometric equation. And so you can see they use the trig identity here. Sine u plus v. And they said that's equal to sine u cosine v plus cosine u sine v. Okay, so we have to know that. We have to memorize that. And that's what they did down here. They went ahead and did that, and they noticed that, hey, this right here and this right here are the same thing, only the signs are different, so they cross out. And then I noticed that this is the same as this, so now I have two of them. Okay? So, let's see. Then I noticed that the 2's cancel because the cosine of pi over 4, or 45 degrees, is this. We knew that because, we know how to draw a 45 degree angle right here. We know 1 square root of 2 from our reference triangle. So we're like, oh, hey, 45 degrees. And then we divide both sides by the square root of 2. And we get sine x is equal to negative. Oh, negative. Okay, so at this point we're like, okay, change of plans. We have 45 degree angles down here and down here. Okay, so there's our new situation. And square root of 2 and square root of 2. We're in quadrant 3 and 4. And so this is the one in quadrant 3, this answer. And this is the one in quadrant 4, right here. And they say, hey, you could just graph it. And if you graph this, you find out that, oh, it crosses the x-axis at 3.927. And you say, 3.927, that's weird. Well, if you think about the fact that 5 over 4 is 1.25, and you're multiplying that by pi, which I guess I should write as 3.14, you'd say, okay, I can see how that'd be 3.9. And 5.498. If you think about the fact that 7 over 4 is 1.75, and you're multiplying it by 3.14 for pi, you could see that that's not such an unreasonable answer from the graph. Okay, so right there for my purple. Okay. And you can see how we do this from the graph. Of course, I want you to show me how you do it algebraically, but, you can check your work. So anyway, here we go. We have the sine of u plus v. So let's see. That's going to be the sine of x, cosine of pi over 3, plus cosine of x, times the sine of pi over 3. Pi over 3 being 60, right? And then, okay, so that's that part right there. I'm doing that part in green. And then I'm going to do this in purple. And so I have plus the sine of x and the cosine of pi over 3. And then sine would never change the sign, so it's negative. And then it's cosine x and sine of pi over 3. And we're equal to 1, or we're supposed to be. So we're going to verify. Oh, well, not verify. We're actually going to find the solutions. So I think that 1's coming over to the other side, right? If you look up here, well, maybe not. Okay. So let's go back down here. We're going to find the values of x that are going to work for that. Okay. So, and then we can verify our results by graphing. I'll probably do that. Since I haven't done it beforehand, I will do it after and add the graph as an afterthought. So, let's see here. What happened? Did we get the same kind of canceling action? It looks like we did. This right here is the same thing as this right here. And they're going to take each other out, right? They're going to take each other out. One's positive, one's negative. And we're going to end up with 2 of these, sine x cosine pi over 3. And we say, what is the cosine of pi over 3? Well, okay, let's draw this angle here. And we'll say, if this is 60, then it's opening up on the square root of 3, and 2, and 1. And so we're going to say the cosine of pi over 3, which is what this is right here, pi over 3, is 1 over 2. It's 1/2, right? So we're going to say 2 sine of x times cosine of pi over 3 is half. Okay, and oh, by the way, it's equal to 1. Don't forget that. Oh, yeah. Okay, so we say, hey, the 2 is going to cancel, and I'm just going to have sine of x is equal to 1. And I think to myself, well, where is the sine of x equal to 1? And this seems to be a theme today because, as you recall, there's only one place where this happens. Let's see the limitation. 0 and pi, well, that's not much of a limitation, is it? So it goes up and it goes down. And there is only one place. It's up here at pi over 2. Okay? So that means that x is equal to pi over 2, because that's the only place that sine is equal to 1. And I know it's equal to -1 down here, but that's not the same. Okay? So there we go.